use the law of cosines, explain how the formula is derived, and show how it is used in solving problems.
Good day everyone, I am Glyza Maata and I will be talking about complete triangle. Before we proceed, let us review some important ideas. A triangle does not contain an 90 degrees is called oblique triangle. The right triangle, we usually use Pythagorean theorem. But in oblique triangle, we use different formulas. So this is where law of cosine be useful. So what is law of cosine? Law of cosine is also known as cosine formula or cosine rule. It is a generalization of Pythagorean theorem. It relates the length of a side of any triangle. Triangle C squared is equal to A squared plus B squared minus 2AB cosine. So C is an opposite side of C. This formula allows us to find the missing side or angle in dealing with oblique triangle.
So, we have here triangle ABC, and this is a good example of an oblique triangle because as what we can see here, it does not contain any right angle. Now, I recall in naming triangles, we use capital letters for its angles and small letters for its sides, just like what we have here. And these three are the formulas for the law of cosines. And yeah, we have here a squared is equal to b squared plus c squared minus 2bc cosine a. B squared is equal to a squared plus c squared minus 2ac cosine b. And c squared is equal to a squared plus b squared minus 2ab cosine c. Now, the question is, where do these formulas came from? Well, that's what we are going to find out. We will derive these formulas and yeah, let's go. To do this, we are going to drop down an altitude from angle C down to side C, just like what we have here. And we label this one as H, which stands for height. Now, we can see that triangle ABC splits into two. We have here this one on the left side and this one on the right side. Now, since C has also been splitted, because what we can see here, we have here this one and this one, we are going to name this side as X and this one as C minus X, because again, if this is X, then this must be C minus X. Now we have written X here and this one as C minus X. And also, we are going to label this point here as D for our reference later. So, at this point, we can use the Pythagorean theorem because we now have two right triangles. And yeah, let's start with this one. So, for triangle BCD, we have a squared is equal to the quantity of c minus x squared plus h squared. Now, we are just going to expand this one and we will get c squared minus 2cx plus x squared, copy this one, plus h squared. Now, we are just going to set aside first this one because we will move to triangle ACD. For triangle ACD, we have b squared is equal to x squared plus h squared. Now, notice that we can isolate h squared so that we will have a value for this one. We can substitute it here. And yeah, that would give us h squared is equal to b squared minus x squared. And we are just going to put this one in here. Now, we are done substituting b squared minus x squared to h squared we now have here. And the next thing that we're going to do is we are going to combine like terms. Now, we can see that we have here positive x squared and negative x squared. So we can cancel out those ones. So, cancel. And there's nothing more, so we're going to write here a squared is equal to c squared minus 2cx plus b squared. So notice that we have x here, and as what we have all known, we just made that up earlier for this side so that we can have a value for this side and this side. So the next thing that we're going to do is to get rid of this x. Now to do that, we are going to look at these two triangles and see or look at which triangle that contains x, and we have this one, the triangle ACD. So in triangle ACD, we can use the SOHCAHTOA, specifically the CA, which stands for cosine is equal to adjacent over hypotenuse, so that we can find the value of x, since we have here x, yeah, and this side is the adjacent and hypotenuse b. So we have here cosine A is equal to adjacent x over hypotenuse b. And the next thing that we're going to do is to cross multiply it. So we have here x is equal to b cosine A. Now, we have found the value for x, which is b cosine A, and we're just going to substitute that value into our equation. So now we have a squared is equal to c squared minus 2cb cosine A plus b squared. And the next thing that we're going to do is to arrange this one, and that would give us a squared is equal to b squared plus c squared minus 2bc cosine A. And yeah, we have now derived the first formula, and the rest will follow. So, we made it.
So let us now apply the law of cosine in an example. Suppose a triangle has two sides measuring 6 units and 8 units with an include angle of 60 degrees. Since we use c squared is equal to a squared plus b squared is minus 2ab cos c. Then we have now c squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 cos 60. Since we all know that 6 squared is equal to 36 and 8 squared is equal to 64. Then we multiply 6 times 8 is equal to 48. So if we put this cos 60 degrees in our scientific calculator, we will come up into 0.5. Then since we have 36 here and 64, if we add these two, we will come up into 100. Then if we multiply this one, 2 times 48, it will come up into 96. Then if we compute this all, we will come up into 52. Since RC have a squared, we need to put radical sign to cancel out the squared. Then we have now square root of c squared is equal to the square root of 52. Then we will cancel out the square root. Then we have now c. Then 52 square root of 52 is equal to 7.211. So that the missing side measured 7.21 or approximately 7 units.
In this video, I will show you how to find an angle of a triangle when all three sides are given using the law of cosines. Example 2. Finding an angle. Now, let us solve an example where all three sides are given. Suppose the sides measure 5 units, 7 units, and 9 units, and we are asked to find an angle opposite the longest side. I will teach you how to solve the problem. First, we write the law of cosines. Cosine C equals E squared plus B squared minus 3 squared over 2AB. The longest side is 9 units, so we are finding the angle opposite of the side. Step 2. Given values. We identify the given values. Side A is equal to 5 units. Side B is equal to 7 units. Side C is equal to 9 units. The longest side is 9 units, so we are finding the angle opposite of this side. Step 3. Substitute. We substitute the values into the formula. Cosine C is equal to 5 squared plus 7 squared minus 9 squared over 2 times 5 times 7. Step 4. Simplify squares. 5 squared is 25, 7 squared is 49, and 9 squared is 81. So we have cosine C is equal to 25 plus 49 minus 81 over 70. Step 5. Simplify. Now we simplify the numerator. 25 plus 49 minus 81 is negative 7. So, cosine C equal negative 7 over 70. Step 8, the final answer. Finally, we take the inverse cosine. C equals cosine inverse of the negative 7 over 70. This given us C approximately 95.7 degrees, or about 96 degrees. Conclusion. Therefore, the angle opposite of the longest side is approximately 96 degrees.
We have also special case. If an angle is equal to 90 degrees, then cosine 90 degrees is equal to 0. When this is substituted into the formula, the law of cosine becomes Pythagorean theorem. This shows that cosine is a general form of Pythagorean theorem.
To sum it up, the law of cosines is used to solve oblique triangles. It is especially useful when two sides and an included angle are known or when all three sides are given. We also learned how the formula is derived from the Pythagorean theorem. And yeah, that's it. Thanks for watching. Bye-bye.